Hi everyone! Today we're going to be going over 1.3 algebraic expressions. This should be mostly a review from material that you learned in Algebra 1. Our lesson objectives are to evaluate algebraic expressions and to simplify algebraic expressions. You're going to need a notebook and a pencil for this lesson. So the first thing I wanted to do was go over some key phrases that you talked about in Algebra 1, but since it's been over a year since you've been in Algebra 1 class, I want to make sure that we remember some of these phrases. So the first one, 7 more than a number x. If you were to write that as an expression, it would look like x plus 7. The reason for that is we're saying take whatever the value of x is and add 7 more to that. The word that is key here is the than. Anytime you have more than or less than, you're going to flip the order of the numbers. So looking at number 2, 7 less a number x, there is no than involved. So you're taking 7 and you're subtracting x from it, so you would get 7 minus x. On number 3, it says less than, so again, you're going to be switching that order. So you want to take whatever x is and you want to go 7 less than that. So you would get x minus 7. The fourth one says the difference of 2 and the number x. The difference is the answer you get when you complete subtraction. So this means to subtract 2 and x from each other. The sum of 2 and a number x, sub means addition. So that means you want to add the two numbers together. And then the last one I included says the quotient of the number x and 4. The quotient means the answer you get when you divide. So that would look like a fraction, x divided by 4. So we're going to be using some of these key phrases, so we want to make sure that we know what they mean. So the next question says, which algebraic expression models the word phrase? And then our word phrase is 7 fewer than a number x. So what this means is you're going to start with x, and you're going to take 7 fewer than that. So we want one that uses subtraction, and we want our starting value to be x. So if you look at our 4 choices, you should hopefully see that choice C is the correct answer. You're taking x and you're going 7 fewer than that. The next one says 2 times the sum of a number A and a number B. Whenever you have multiplication, so this means 2 times, and you have this word, the sum, what they want you to do is they want you to do that multiplication with the answer you get after you add. And the only way you can do addition before multiplication in order of operations is if the addition is in parentheses. So looking at here, all of our choices, the only one that's going to have you do the addition first is choice B. This is saying add A and B together, get whatever that answer is, and then double that. Take twice of it. Now we're going to look at writing expressions that can model real-world situations, and there's 3 things we want to make sure that we're doing. Identifying the actions that suggest operations. So what are some actions that would result in you adding, or subtracting, or multiplying, or dividing? Define one or more variable to represent the unknown. So anytime there's something that you don't know what that value is going to be, you want to make sure you're defining it whenever you use a variable. And then number 3, represent the actions using the variables and operations. That just means actually go ahead and write that expression. So our first example, you start with $20 and save $6 each week. Write an algebraic expression to model the total amount you save. So I'm going to walk you through this one, again, using those steps like they described on the last slide. The first thing we want to do is identify the actions. Okay, so that's my plus and my times. And we want to make sure that we're defining any unknown values. So you have your starting amount, and then you're going to add to that the amount you saved times the number of weeks that you're saving. We know our starting amount. They tell us that in the problem, so we know that this is $20. We're going to be adding to it the amount that we save each week, so I'm going to insert a plus sign. We know the amount that we're saving. They tell us that we save $6 each week, so I'm going to put 6. We're going to multiply that by the number of weeks. That is our unknown. Nowhere in here did they tell us how many weeks we're going to be saving. So I'm going to use a variable. I'm just going to use W to represent the number of weeks. Before I can finish my problem, I need to be sure to define that variable that I used. So I'm going to say W is the number of weeks. And this would be our final answer. We have our expression and we've defined our variable. All right, the next one says, in football, a touchdown T is worth 6 points, an extra point kick K 1 point, and a field goal F 3 points. What algebraic expression models the total number of points that a football team scores in a game, assuming each scoring play is one of the 3 given types? Then it says, suppose a football team scores 3 touchdowns, 2 extra point kicks, and 4 field goals. How many points does the team score? So we're going to tackle the first question first, which asks us to write that expression. That will help us then to solve for the second question. What's nice about this problem is they've provided to you the variables and they've also defined them in the question. They said a touchdown T. That's defining the variable T as being the number of touchdowns. So they've taken that off our plate. We don't have to do that. The operation that you should be seeing is that every touchdown is 6 points, which means you're using multiplication. You're going to do 6 times however many touchdowns they get. For extra kick, it's 1 point times the number of extra points that they kick. And then for field goals, it's 3 times the number of field goals. So to write our expression, what that would look like is 6 times the number of touchdowns plus, now when you do 1 times a variable, you don't need to put the 1 out in front of it, so I'm just going to put K plus, and then it's 3 times the number of field goals. So this would be our expression that they asked for in the first question. The second question gives you a scenario where the team has 3 touchdowns, 2 kicks, and 4 field goals. In order to figure out how many points they have, we're going to plug those numbers in and simplify. So 6 times 3 plus 2 extra points plus 3 times 4. And now I'm just simplifying. 6 times 3 gives me 18 plus 2 plus 12, and add those all together, you should get 32 points for your football team. For the next one, up here we have this definition of evaluate. You're going to see this a lot, and you definitely saw it in Algebra 1. This just reminds you that to evaluate an algebraic expression, you're going to substitute a number in for each variable in the expression, and then simplify using the order of operations, which if you forgot, that is PEMDAS. Okay, parentheses, then exponents, and then multiplication and division you can do interchangeably, and then addition and subtraction, the same thing. So what is the value of the expression for the given values of the variables? They've told us that A is -4 and B is 5. So I'm going to take those values and plug them in anytime I have a variable while keeping all of the parentheses and all the other information. So 7 and then parentheses, we have -4 for A plus 4 plus 3 times 5. Anytime your number is stuck right next to your variable, you're multiplying, and then -8. Now I'm going to follow order of operations. So parentheses first, -4 plus 4 gives me 0. So 7 times 0 plus 3 times 5 -8. Now you could have done that multiplication, it still would follow order of operations. So if you know some of those tricks, feel free to use it. Next would be exponents. We don't have any. So now I'm going to move to multiplication and division. 7 times 0 is 0. 3 times 5 is 15, and then I have -8. The 0 you don't even really need because 0 changes nothing when you're adding it. So really we're just looking at this 15 minus 8, which is going to leave us with +7 as our final answer. All right, for the next one, I'm just going to actually leave that because it fits there and we want to remember PEMDAS. Here we do have some exponents that we need to be aware of. I'm going to again plug in 6 for x and -3 for y. So I get 6 squared minus, now I'm going to put my -3 in parentheses because when you square a negative, you want to make sure that you're squaring the negative sign as well. Okay, because a negative times a negative, it should give you a positive. And if you don't put it in parentheses on your calculator, it will come out as a negative number. And that's all being divided by 3. So now I'm going to start with parentheses. Within my parentheses, I have these exponents that I need to take care of before I can do my subtraction. So I get 6 squared is 36 minus -3 times -3 is going to be positive 9. So that negative in front of the 3 actually goes away. All being divided by 3. Then I'm going to do this subtraction in order to get rid of my parentheses. 36 minus 9 is going to give me 27, all being divided by 3. Now you could do the multiplication here first and then divide by 3, but I actually noticed that 27 divided by 3 is simple division. So I'm going to do that first because as we said, multiplication and division are interchangeable, meaning you could do the division first and then multiply after. So that leaves me with 2 times 9, and 2 times 9 I know is 18. All right, and then the last 2 problems we're going to look at have us combine like terms and write each form in the simplest form, or write each expression in the simplest form. So to do that, like terms, they need to have the same variable factors. And what that means is not only do they have to have the same variables, but they have to have the same variables with the same exponents. If you have x squared, that would be the same thing as 7 times x times x. But when you have x cubed, that would be -4 times x times x times x. So those are not the same variable factors. X cubed has an extra x that x squared doesn't. So you cannot combine them as like terms. So keep that in mind when you're dealing with exponents. In this expression, the only 2 that are like terms are our y squareds. So I'm going to combine those for 5y squared, and then I'm going to bring everything else down. So minus 4x cubed and my 7x squared. This is simplest form. There's nothing else that can be done. There's no more like terms that we can simplify. Looking at our last question, the first thing I need to do is distribute. In order to get rid of my parentheses, you can't combine like terms until your parentheses are gone. So to do that, I'm going to distribute this -1, and I'm going to distribute this -10. Please be careful that you look at the signs when you're distributing to make sure you're distributing the correct number. If you only brought over the +10, you would not get the correct final answer. -1 times 8a is going to be -8a. -1 times 3b is going to be -3b. -10 times 2a would be -20a. And then -10 times -5b would be +50b. And now we can worry about our like terms. So our a's are going to be like terms, and then our b's are going to be like terms. -8 minus 20a, those are both negative, so you add and keep the sign, so -28a. And then our b's, -3b plus 50b, that's simple subtraction, so 50 minus 3, we're going to get +47b. And this is in simplest form, there's no more combining that we can do, so that would be your final answer. All right, so that is 1.3. Hope you guys enjoyed it.